Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of dilation representations. This is standard 8.3c in the great state of Texas, and we are using item number 36 off the 2017 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got this quadrilateral F, G, H, and J, which is the smaller one. It's dilated to create a slightly larger one of this F prime, G prime, H prime, J prime. So how do we represent that? We go from F, G, H, J. So let me put that right here. Since we've got our answer selections here kind of lined up, the left column is going to be F, G, H, and J. And then our right column is going to be our prime, our new quadrilateral. So that's going to be helpful because what we need to do is we need to look at scale factors. And so we need to remember these two rules. When your scale factor is greater than 1, that means it grows or it gets larger. And so it could be you're multiplying by 2, you're multiplying by 5, multiplying by 10. We're wanting to get it larger. But when your scale factor is less than 1, so that's going to be a fraction, well, guess what? It's going to get smaller because you're multiplying by less than 1. So you're taking half of it, a third of it, fourth of it. Now, what we need to do in order to create a dilation is actually in this term factor. A factor is something that we multiply, right? When we do 3 times 4 equals 12, these two are factors, right? So that kind of gives us our hint that when we are trying to dilate a shape, we need to multiply our scale factor by the x and y coordinates. And you see that we're not doing that in all of our answer selections. In G, we are doing a +1 and a +2. So let's see what that would look like. So if we're just looking at our original trapezoid right here, if we were to do a +1 to the x, right, that means we would take it over 1. And then if we were to do a +2 to the y, we would go up 1, 2. So we would take this whole shape and move it over 1 and up 2. So basically kind of diagonal a little bit like that. But it would not increase the size. It would stay the exact same size. So you wouldn't have a larger shape outside of a smaller shape. You would just have two shapes that are kind of overlapping because both this one and this J, which is not going to work, these two are not dilations, they are translations. We're just sliding them because you're just adding. Scale factor means you need to multiply. So let's look what our two options are. We are going from a smaller trapezoid to a larger trapezoid, and this is where the scale factor information becomes important. Take a look at this 5/7. 5/7 is less than 1. Which means if we were to use that as our scale factor, our F prime, G prime, H prime, J prime would be smaller. But it's not smaller. We actually need it to get larger. So look at the only thing that is larger. It's this 1.4. Now, we don't even have x and y coordinates for this particular graph. We don't necessarily need them. We just need to apply our knowledge of these scale factors to know that we're taking our x and we're going to multiply by 1.4. So it's not even going to get twice as large. It's going to get about 40% larger. And so you see how each of these points are just a little bit larger so that it looks like one trapezoid is outside of the other trapezoid. This is the only possible option. Now, if we had two options in our answer selections that were greater than 1, then we'd actually have to plot some points and figure out which one it is. But that's the only one it could be because that is the only one that has a scale factor greater than 1, h.